A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise, because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come. So, dark matter is a mysterious substance that makes up about 85% of the total matter in the universe, yet we can't see it or touch it. The regular matter that we're used to forms stars, planets, and everything around us. But dark matter doesn't emit, absorb, or reflect light, which is why we can't even see it. We don't even know if it actually exists. The reason why we believe in dark matter is because it leaves gravitational effects on galaxies and other cosmic objects. For example, spiral galaxies spin in a way that doesn't match the law of physics we know. According to our current knowledge, the outer edges of these galaxies should slow down, but they don't. They either keep the same speed or even speed up. It also seems to be acting like an invisible glue that holds galaxies together. If dark matter didn't add some invisible gravitational mass, the galaxies would literally break apart, not being able to hold stars together. But even though it's fundamentally important for our world, we still don't know exactly what dark matter is made of. This has been going on for years. Some experiments saw hints of it, but no one's been able to prove it beyond a doubt. Maybe the future Circular Collider will be able to find it. There's a mysterious force in space that seems to be pulling our entire galaxy, along with many others, toward it. This force is known as the Great Attractor. Wink, wink. It's a crazy massive region in space, about 10 million billion times the mass of our Sun, with a super powerful gravitational pull. Scientists think it might be a super cluster of galaxies, but they're not sure. The problem is, we can't see it directly because it's hidden behind the Milky Way, while the Milky Way itself, horrifyingly, is moving toward it at a speed of about 370 miles per hour. Now, just like with dark matter, we only know it's there because of how it affects the movement of galaxies around it. These galaxies are being pulled toward this region, even though, since the universe is expanding, they should be moving away from each other. What's even weirder is that this Great Attractor might itself be moving towards something even bigger, the Shapley supercluster. It's the largest concentration of galaxies in our nearby universe. In 2017, astronomers discovered a strange object called AMMUA. This was the first known visitor from another star system. The thing was quite small, from about 330 feet to about 0.6 miles long. It was also long and thin, had a reddish color, and moved in a very unusual way. As it passed by the Sun, it unexpectedly sped up and then left our solar system just like that. Tons of theories started sparking up. It was too weird looking for an asteroid. Scientists thought it might be a comet, but it didn't have the usual traits of one, like a tail of gas and dust. Eventually, some scientists even started to suggest the wildest theories, like it might be an extraterrestrial probe. People have been making a huge fuss about AMMUA ever since. But after a while, it turned out it was just a natural object with unique properties. It was probably a fragment from a distant star system, like a piece of a disintegrated comet or even a chunk of a planet. But AMMUA caught everyone's attention so much that in 2022, astronomers even proposed to send a spacecraft to catch up with it. This mission could take about 26 years. Hey, stay tuned. Now, as for extraterrestrial creatures, where is everyone? There's this thing called the rare Earth hypothesis that suggests that life as we know it is actually super rare in space. In the 70s and 80s, scientists argued that Earth is just an ordinary planet in an ordinary solar system. If we look at it this way, life should be widespread across the universe. It seems unreasonable to think that with trillions of planets out there, there will be no planet like ours anywhere. But then, a geologist, Peter Ward, argued that the development of complex life like ours depends on a very rare combination of things. The history of the planet, with all of its astrophysical and geological conditions, should line up perfectly for complex life to develop. So just think about it. Being in the right zone of the galaxy, on a good distance around a stable star, a rocky planet with water and the right temperature, emergence of molecules, monkeys deciding to walk, and so on. This would explain the Fermi paradox, which asks, if extraterrestrial life is common, why haven't we seen any signs of it? Well, the rare Earth hypothesis explains it. The universe might be full of plants, extraterrestrial critters, and fun animals. But would there be an intelligent species like humans? That's another story. As for humans being intelligent, that's another matter. Dark matter? And even if they do exist, we could be incredibly far away from each other. That would make communication or contact with other intelligent species very unlikely. Now, there's another similar theory called the Great Filter. This idea says that there might be a big obstacle somewhere along the path from microbes to advanced civilizations. It was the idea of the economist Robin Hanson. He also believed that maybe intelligent life, as we know it, isn't that common in the universe, although he assumed it's not because our planet was the result of tons of unique conditions, but because there must be some sort of filter that reduces the chance of life progressing to our point. Who knows where this filter is? It might be in the stage of early microbes, which means that we managed to get through it or somehow ahead in the future, which means we might go extinct like many other species before us. Well, maybe in the next stages. such as colonizing other planets and the galaxy, are much harder, if not impossible. Something unexpected might come up: potential catastrophes, resource exhaustion, or other challenges. Now, there's this thing called a pulsar. It's a weird type of star that sends out regular bursts of radio waves, like a flickering space lighthouse. You see, in space you often find a pulsar and a smaller companion star that rotates around it. But one day, scientists discovered this system, which was also surrounded by tons of some energetic material. They suddenly realized that these are probably the remains of another companion star, which was very big in size. But the pulsar was blasting out powerful radiation and particles, slowly consuming its companion. This is kind of like how a black widow spider eats its mate, hence the name. Since then, they've found other similar systems. They've grouped them all into one spider family. There are also redback pulsars, which destroy slightly larger companions, and huntsman pulsars, which have companions that are massive enough to resist being completely destroyed. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they've failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, But seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step: activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. Over billions of years, the surface of the Moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed. So when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moondust adds another layer of complexity because without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Sweep Mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many, many, many times the current age of the universe for it to completely evaporate. We found a water cloud in space around a black hole. It's a gigantic water reservoir that's located about 12 billion light-years away from Earth. This must be the largest and farthest water reservoir ever detected in the universe. This one cloud contains an astonishing 140 trillion times more water than all of Earth's oceans combined. That's wet. The water surrounds a quasar, which is basically an incredibly energetic supermassive black hole. This quasar is about 20 billion times larger than the Sun and emits as much energy as 1,000 trillion suns. You do the math. As the black hole slowly consumes everything around it, it releases energy. This energy heats the surrounding gases and dust, causing the formation of water vapor. As a result, the black hole is surrounded by a huge water cloud and all the other gases and dust bath around it. This pair formed when the universe was only 1.6 billion years old, just a fraction of its current age. That means that the water isn't young at all and has been existing in galaxies for billions of years now. This quasar will only keep getting scarier and bigger. If it eats up all this gas and dust around, it could grow up to 6 times its current size, potentially becoming 120 billion times larger than the Sun. Think about that.
Many sci-fi movies can make you believe that everything happening in space is accompanied by some kind of sound effect, which is a totally false misconception. In space, no one will hear you scream. There's no air in space. It's an almost perfect vacuum. And the sound waves don't travel through a vacuum. They can't reach your eardrums and make them vibrate, sending signals to your brain. But it's a good thing, especially for astronauts on spacewalks. If not for the quietness of space, they would be constantly overwhelmed by the noise of solar storms. Huge space explosions sure look super impressive. Whether they're scientifically possible or not is another question. Blasts on our home planet look the way they do because of air and gravity. You see, the air functions as an oxidizer, and the outward pressure makes everything fly into the air and then collapse back to the ground. But this process is very different in space, and it looks even cooler. If a blast occurred in space, there would still be some fire despite the lack of air, because some kinds of fuels can act as oxidizers. But it wouldn't be the fire you're imagining now. This cosmic fire would look like an expanding ball of light. It would be a seemingly never-ending process due to microgravity and the lack of air resistance. Nearby spaceships would be in grave danger since the shrapnel would fly outward until something eventually stops it. All comets have beautiful long tails. Huh? It's nothing but a popular misconception. In reality, comets are very difficult space bodies to spot. They usually spend large amounts of time far away from stars. There, in the darkness of space, they remain rather inactive and completely frozen. Comets only get tails once they come close to a star. That's when they start warming up. This process makes them form some kind of a cloudy atmosphere, which is called a coma, and a distinctive tail. The tail always points away from the star that influences the comet. It happens because the tail gets blown in the opposite direction by solar radiation and solar winds. That's why the tail can often be in front of the comet, not trailing after it. The inner and outer planets of the solar system are separated by the asteroid belt, a ring of asteroids and other debris and space objects orbiting around the Sun. While creating movies about space, filmmakers make sure to somehow use this region. Usually, they show the asteroid belt as an extremely crowded place with dense clouds of huge rocks you have to skillfully maneuver to get through to the other side. In reality, if you looked outside your spaceship while flying through this region of space, it would feel as if you're looking at the sky from Earth. All because of the ginormous distances in space. If you decided to cross the asteroid belt, there would be very little chance of a collision with a space object. Asteroids there are really spaced out and very far from one another. Black holes are giant, scary cosmic vacuum cleaners, they say. But in reality, black holes are more like fly traps. They don't look for things to munch on. Instead, they sit out there quite passively. Only when a star or any other object comes too close does a black hole spring into action. Even so, only those space bodies that cross a certain border get ripped apart. In fact, black holes aren't any different from any other celestial body since their pull is directly proportional to their mass. They can't swallow anything bigger than what their size allows. Even if our Sun was somehow replaced with a black hole as massive as itself, nothing would change for Earth or any other planet in the solar system. Gravitationally speaking, of course. Space battles in movies often involve using lasers. But if you were to see such a fight from up close, you would probably be disappointed. The thing is, it would be like nothing in movies. A laser beam is a concentrated burst of energy, and it could indeed be used for many purposes during a fight. But a real-life laser beam would be totally invisible in space since there wouldn't be any particles around to scatter the light and make the beam bright red or green or any other color. A human would be torn into pieces if they got into open space without a spacesuit. Well, contrary to popular belief, taking off a spacesuit during a spacewalk wouldn't be as dramatic as it's often pictured in movies. A person would just lose consciousness due to a lack of oxygen after 15 seconds of being in outer space without protection. But that's if this person breathed out as much air as possible. Otherwise, this oxygen would damage their lungs from the inside, making them rupture. After that, without the protection of the spacesuit, the pressure inside their body would drop. This would cause even more serious trouble. And even though this person definitely wouldn't burst, they wouldn't want to stay outside for too long. People often believe that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon orbits Earth and the Sun doesn't float away out of our home Milky Way galaxy. Astronauts on the ISS do experience the effects of gravity, but that's not full-fledged. It's microgravity. The gravity on the space station is only 10% weaker than the gravity on Earth's surface, but astronauts are constantly in freefall. The spacecraft, people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they are very different things. A light year must mean time, right? Not really. Light years actually measure distance. NASA's definition of a light year goes like this: the total distance that a beam of light moving in a straight line travels in a year. And since light moves at a speed of 186,000 miles per second, a light year equals almost 6 trillion miles. It may seem as if the sun is always on fire. At least that's what it looks like in pictures and in movies. But in reality, our star is a giant ball of gas. Nuclear reactions happening in its core at all times make the sun burn. Every second, hundreds of millions of tons of hydrogen are converted into almost as much helium. During this process, huge amounts of energy are released as gamma rays. Then these rays turn into light. In other words, the sun does emit blinding light and incredible heat, but it's not actually on fire, because no oxygen is involved in the process. The speed of light is believed to be the ultimate barrier for people when it comes to space travel, and it's often thought to be impassable. There are many theories about what it might be like to reach that speed, but none of the equations account for going above it. And still, we know that at least one thing in the universe is faster than the speed of light: the rate of its expansion. Yep, the universe is expanding faster than the speed of light, baffling astronomers and casual sky watchers alike. Or at least we can say so in terms of the speed of different objects, like faraway galaxies relative to each other. At the moment, it's not something scientists understand well. The rate of the expansion of the universe is proportional to how far something is, too. The farther it is from us, the faster it's moving away. But even though we don't get the mechanics of it yet, we've got our proof, even though it's theoretical so far, that some particles might be able to travel faster than the speed of light. Some scientists think there could be more things out there in space that could challenge this speed barrier. All we need to do is find them.
Does the universe ring like a crystal glass? Maybe. But it doesn't mean that it literally rings and we just don't hear it. It just vibrates. Many of you know that the universe started with the Big Bang around 13.8 billion years ago. I wasn't around then, but we can assume. The whole enchilada was born from a super concentrated, hot, and dense tiny dot that contained everything. When it couldn't bear its pressure anymore, it made a huge blast and spewed around all the time, space, matter, and antimatter like a Pokeball. After being born, the universe moved at a breakneck speed. Imagine standing in the middle of nowhere, you blink, and suddenly you're surrounded by the universe. That's what it would feel like. It started growing and growing, and eventually, its speed got slowed down a bit by gravity. Gravity started pulling all the matter together, slowly helping new things like stars and galaxies to form. Okay, makes sense so far. The Big Bang gave the universe a big push, accelerating it. Logically, everything should eventually slow down and start moving at a constant speed, or even stop, right? Well, nope. In the late 90s, astronomers discovered something weird. They looked at some supernova around us, and for some reason, these supernovas were super far away, much farther than they were supposed to be. In other words, the expansion of the universe is not only continuing after all these years, but it's even accelerating. After years of study, they discovered the concept of dark energy, a mysterious force that makes up about 68% of the universe's total energy. This energy pushes it to expand even faster over time. And now, scientists have proposed a new discovery. Perhaps the universe's movements are a bit, well, wobbly. It seems like the universe's expansion hasn't been smooth and stable over the years. Instead, it has undergone periods of speeding up and slowing down multiple times. Astronomers counted about 7 cycles of this acceleration and deceleration over the history of our universe. This can be compared to the oscillation of a crystal glass. When you strike a crystal glass, it vibrates, oscillating at its natural frequency. It goes through fluctuations in which the frequency rises and falls. Over time, it calms down and fades away. Well, something like this is happening to our universe. You can imagine its speed also fluctuating like that, rising and falling, first super rapidly and then more calmly. As if it's not just different waves traveling through it, but our entire world is like one huge ringing wave. The discovery was actually made by accident. Astronomers were working on dark matter modeling. They plotted a new graph called the Hubble diagram, which shows how big the universe got over the years, measured in supernovas. Supernovas are like some lighthouses of our world, helping us mark things on a map. That's when they found these oscillations. But we still need to check all the data to make sure that this discovery is indeed true. Dark energy and dark matter play this weird game with the universe, where one is constantly trying to pull everything together, while the other one wants everything to expand. So far, dark energy vastly outweighs dark matter, whose weight makes up only 27% of the universe. Now, both of them are invisible to us, and not just invisible to our eyes like infrared, it's that we literally can't detect them in any way. We can only assume that they exist based on how they influence gravity, changing entire galaxies, and all the large-scale structures of the universe. We basically made them up because it was the only way to explain how our world works. Dark energy is uniformly distributed across space and time, and we're still not sure what exactly it is. Some theories say that it could be a property of space itself, quantum fluctuations, or even a new type of field or particle. But all we have for now is an invisible energy that pushes the universe to move very fast. If one day we learn more about it, this will help us predict the entire fate of our world. Depending on how exactly dark energy works, the universe may continue expanding and growing indefinitely. Or maybe one day, it will experience the Big Rip, where all matter will be completely torn apart. Okay, here's to hoping we're not all around for that. Meanwhile, dark matter, also invisible and yet to be proved, works the opposite way. It's not energy that accelerates things. Instead, it's more like a glue that tries to hold everything together. It's a type of matter we can't detect because it doesn't emit, absorb, or reflect light. We don't even know what particles make up this thing. We still can't catch them. At first, we thought it might be made up of regular heavy particles, like the one that makes up our world. But after years of research, they haven't found even a single one. So now they think maybe it's actually made up of ultralight particles, millions of times lighter than anything we know, and because of that, we can't even notice them properly. So now, astronomers try to detect not the particles themselves, but waves that they could leave as they move through space. But we believe that it exists, because if it didn't, our galaxies wouldn't hold together. Dark matter helps them form, grow, and rotate. So, about 85% of our world is made of something unknown. All of this is incredibly mysterious and needs a lot of research. But that's what we know now. Maybe in the future, we'll discover something that will completely change our perception of the universe. That's what happened to Albert Einstein. In the early 20th century, most scientists, including Einstein, believed that the universe doesn't actually move. They thought it was static, neither expanding nor contracting. That's because, to us, it feels like it doesn't really move. Back then, scientists didn't have powerful computers or telescopes that could detect all the little changes in the positions of stars and supernovas. When Einstein developed his famous general theory of relativity in 1915, his equations actually suggested that the universe should either be expanding or contracting. This didn't really make sense to him. To fix this calculation flaw, he decided to introduce a new term, the cosmological constant. It was like a repulsive force that counteracted the attractive force of gravity. Essentially, it meant that while gravity tries to push everything together, some force or energy helps to balance this out by pushing everything apart. Sounds familiar? Then, in the 1920s, astronomers Edwin Hubble and Georges Lemaitre found out that the universe isn't static, it actually expands. They noticed a slight reddish tint from the distant galaxies, and this tiny hint meant that other galaxies were moving away from us. After that, Einstein scratched out the cosmological constant. Interesting how he was later ashamed of this assumption, calling it his greatest blunder. He didn't even know that he was 100 years ahead of his time, accidentally discovering dark energy. Now the cosmological constant is back again, just in a new form. Something similar happened with dark matter. Scientists have already started noticing that something doesn't add up back in the early 20th century. They saw that galaxy clusters didn't have enough visible mass to hold them together, which means there must be some unseen mass that helps to make up for it. And that's when it got its name, the dark matter. This stayed unresolved and unproven for many years. And then it was finally discovered by Vera Rubin when she was observing galaxies and their movement. She realized that outward parts of galaxies move almost as fast as their central parts. This doesn't really make sense. The outer part should be a bit slower. This became the first official proof of dark matter, which boosted its research. There are still many things left to be discovered, but maybe one day we'll understand what is this invisible part of our universe that makes it ring. At first, it may seem like the sun is burning, but it's actually not true, because the burning of our star isn't chemical combustion, it's nuclear fusion. The sun can't run out of oxygen or stop burning because it doesn't use oxygen to burn. Regular carbon combustion requires oxygen. As soon as there's no oxygen, the process of burning stops. Now imagine a candle. If you cover it, it doesn't have access to oxygen anymore, and the process of burning stops. But in nuclear fusion, the nuclei of atoms are fused together to make new, bigger nuclei. Such changes cause atoms to become new elements. Nuclear fusion doesn't require oxygen or any other material altogether. You just need enough pressure or heat to squeeze the nuclei of atoms close enough for them to overcome their electrostatic repulsion and bond into one nucleus. In 2027, two teams of astronomers discovered a cloud of water floating in open space. It was the largest and farthest reservoir of water ever detected in the universe. It's a cloud of water vapor surrounding a huge black hole called a quasar, 12 billion light-years away from Earth. The environment around the quasar must be unique to somehow produce such giant masses of water. It was formed by energy waves colliding hydrogen and oxygen atoms together. The cloud contains 140 trillion times the entire volume of water on our planet. It could provide each person on our planet with a planet's worth of water 20,000 times over. Wow! Even cooler, astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Scientists consider it another demonstration that water exists throughout the universe and was present already during its early days. At the same time, before this discovery, scientists had never found water vapor present so far back in the early universe. There is water in our home Milky Way galaxy, but most of it is frozen in ice. Not only water is floating out there in space, alcohol too. In 2009, scientists were examining a massive cloud of gas and dust in the center of our galaxy when they stumbled upon a surprise. There was ethyl formate within the cloud. This chemical is responsible for the sweet flavor of raspberries. They also found one more cool region. This one was brimming with ethyl alcohol, the same type found in many beverages. At the North Pole of Saturn, a mysterious storm is raging. It's ginormous, spanning an area larger than our planet and showcasing a beautiful but baffling hexagonal pattern. No one has understood yet why the storm has such a bizarre shape. After the hexagon was first discovered in 1987, it remained hidden in darkness up to the moment when sunlight exposed it again. Soon afterward, the Cassini spacecraft designed to explore the Saturn system, provided a series of captivating images and even a video of the hexagonal storm. It turned out to be colossal in size. Its estimated depth is around 180 miles, and the eye of the storm is 50 times as large as the typical storm on Earth. The storm is also changing its color from blue to gold. Winds of hydrogen and ammonia surround the storm and move at more than 300 miles per hour. The storm has several centers. Some of them move clockwise, and others follow a counterclockwise direction. The largest vortex appears to be white, and it's twice larger than the standard hurricane on our planet. As for the hexagon itself, it's a jet stream made up of atmospheric gases. Experts refer to it as just a current of air and weather features. But there is one intriguing detail: a vortex sitting at a higher altitude than Saturn's clouds. It looks like a large towering structure. Saturn's auroras, triggered by the planet's magnetic field, are located atop of the hexagon, giving its appearance a mystical vibe. Astronomers have found a giant, likely active volcano near Mars's equator. It was literally hiding in plain sight. It's ancient and deeply eroded, but seems to be still functioning. There may even be remnants of a glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin, recent volcanic deposit, and beneath, glacier ice might still be present. At a distance of 700 million light-years away from Earth, there's a gaping hole, a blank void with no galaxies, stars, planets, or asteroids, literally nothing. The void is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there billions of times over. That's the mysterious Bootes void. It lies in the constellation of Bootes, the herdsman driving the plow around the North Pole. At first, this void had the name of the Great Nothing, but later it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are enormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bootes void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. There is a diamond planet out there that orbits a star in the constellation of Cancer, completing one full rotation in a mere 18 Earth hours. The planet's scientific name is 55 Cancri E. The radius of this faraway world is twice as large as Earth's, and its mass is 8 times greater. The planet is scorching hot, the temperatures on the day side reaching almost 5,000 degrees Fahrenheit. But the coolest thing about 55 Cancri E is that, according to some specialists, at least a third of the planet's mass could be diamond. That's the equivalent of around 3 masses of our home planet. Sounds like big money floating out there in space. How about we calculate how much this planet could be worth? Wait, someone has already done it, and the number is astronomical, pun intended, of course. It's 26.9 nonillion, and if you're confused by this number as I am, that's 26.9 followed by 30 zeros. Now, for comparison, One of the most expensive diamonds on Earth ever is the Cullion. It costs a whopping $2 billion, and its original weight was a mind-boggling 3,106.75 carats. It was, and still is, the largest raw gem diamond ever found. Later it was cut into many small diamonds. The largest of them is Cullion 1, which also goes by the name of Star of Africa. It has a carat weight of about 530, but imagine how much bigger and more expansive the Diamond Planet is. Nebulas are gigantic clouds of gas and dust, and some of them can have really unusual shapes, as if they were made this way on purpose. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, this mass becomes so big that it collapses under its own gravity and forms new stars. Among some of the most beautiful nebulas out there, we must mention the Butterfly Nebula. Its wingspan is more than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it formed from a giant gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. It's what probably makes the whole structure look like an hourglass or a butterfly. The Ring Nebula looks like a giant cloud of dust and gas surrounding an old, almost extinguished star. At first sight, it does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. They must be hungry. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. The pillars of creation look like something out of this world. See for yourself. They're located 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old. On a space scale, they're just babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called pillars of creation, an active star-forming region. Look at this famous image. The blue colors represent oxygen, red is sulfur, and green means the presence of both hydrogen and nitrogen. The pillars are also bathed in the ultraviolet light coming from a nearby cluster of young stars. Unfortunately, the winds from those stars are slowly but steadily eroding the magnificent towers of gas and dust. Far out in space, a ghostly, super-ancient galaxy is floating all alone. It shines with a faint glimmer of starlight and has hardly changed for billions of years. Astronomers have no idea why it's there or how it formed. Meet DGSATI, a living fossil galaxy. It's as big as the Milky Way, but is nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It might mean that DGSATI was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest to our planet black hole ever discovered. The nearest one is called Gaia BH1, Makes sense. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of around 9.6 times that of the Sun. That means it's way smaller than the newly found black hole. Gaia BH3 is located in the Aquila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Now look at this marvelous exoplanet. It resembles a giant eyeball hanging out there in space. But it isn't the coolest thing about it. This distant world, identified in 2017, is one of the most promising places for finding life outside our solar system. The exoplanet is called LHS 1140b, and it shows signs of having a global ocean capped in ice. It's that very iris, a huge region around 2,500 miles across, which is constantly gazing at its host star. The planet has a radius of about 1.73 times the radius of Earth, and is 5.6 times as massive as our home planet. The giant eyeball planet orbits much more closely to its star than Earth does. It needs just around 25 days to complete an entire orbit. If the star were similar to our Sun, such a distance would definitely be too close for life to appear on the planet. But instead, it's a cool and dim red dwarf. That's why the exoplanet lies in the habitable zone of its star, where it's not so cold that all surface water would freeze, and not so close that this water would steam away. At the moment, LHS 1140b looks like the most promising candidate for hosting life in our planetary neighborhood. Solar flares are extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. They occur when there's some magnetic disturbance in the Sun. Then, magnetic field lines in the atmosphere of our star get tangled and snap. This releases giant amounts of excess energy, including ultraviolet radiation and intense X-rays. These twisted lines appear in sunspots. Those are darker and cooler regions on the surface of the Sun. They form when magnetic fields that used to hide deep within our star rise up to the surface. As for coronal mass ejections, or CMEs, which are launched by solar flares, they're sent outward into space. They hit planets, satellites, and basically any objects in their path. Those that come across Earth trigger geomagnetic storms, which in most cases result not only in beautiful auroras, but also in power grid failures and satellite malfunctions. All these extreme solar phenomena, CMEs, sunspots, and solar flares, get much more intense during the peak of the Sun's 11-year-long activity cycle. It's known as solar maximum. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emits powerful streams of radiation, and grows planet-sized spots. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive sooner than that. This planet is as light as a piece of fluff stuck to your jacket. In the scientific world, its name is WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years from us. We'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin. It has an extremely low density. Combined with other factors, like its high temperature and the infrared brightness of its host star, it makes it special. Interestingly, the planet's radius is just 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their planet stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000 plus exoplanets we have already discovered.
In April 2023, astronomers found something exciting: a runaway black hole. This thing is moving through the universe at an incredible speed, about 3.5 million miles per hour. It's 4.5 thousand times faster than the speed of sound. They found it accidentally. Researchers noticed that there was some weird straight line in Hubble images. After some digging, they realized there was a moving black hole. As it moves, it compresses the gas on its path, literally creating new stars along its journey. So it's leaving a beautiful, long trail of stars behind it. And when I say long, I mean it. Its tail is 200,000 light-years long, which is like the length of 2 Milky Ways. Turns out one end of this star trail connects to a distant small galaxy. This is probably where the black hole came from. Most likely there were 2 supermassive black holes whirling around each other. And then another galaxy came along with its own supermassive black hole and ejected one of the original ones like a mean kid, which is why it's called Runaway. There might be a 9th planet with the very original name, Planet 9, in our solar system. If it exists, it's probably somewhere far beyond Pluto. Astronomers think so because some rocky objects near Neptune move in a weird way as if they were influenced by the gravity of a large, unseen planet. Planet 9 might be a gas or ice giant 7 times the mass of Earth. One of the ideas is that it could have existed in our solar system, but then bumped into something huge and ended up with a crazy long orbit around our Sun. If we actually discover it, it could change our understanding of the solar system. A new telescope is coming soon, equipped with the largest digital camera ever built, and it will start scanning the sky in 2025. Maybe it will finally spot this mysterious planet. Another awesome discovery was made in 2023. The James Webb Space Telescope found over 500 planet-like objects in the Orion Nebula. Some of them are roughly the mass of Jupiter, so they're literally called Jupiter mass binary objects, or jumbos. They just float out there with no stars, and they're not really stars or planets themselves. What's even crazier is that in about 42 pairs of them, the objects are orbiting each other, even though planets aren't supposed to do that. On top of that, such large objects shouldn't form and exist without a star at all. So now, astronomers are trying to explain this. Perhaps jumbos have formed in places where there was enough stuff for big planet-like objects, but not enough for stars? Or maybe all of them were ejected from their star systems for some reason. Who knows? But now we definitely need to study them. The black hole in the center of our galaxy, Sagittarius A star, used to be super weird. Luckily, it didn't run away like that other one, but it was completely crazy in the past. Astronomers found 2 supermassive structures called the Fermi bubbles and Rosetta bubbles. They spanned about half the width of our entire galaxy, and they've been towering over the Milky Way for over 2 million years now. And scientists think that it's our black hole that created them. It seems like when it was at its peak activity, it had a wild, energetic eruption that lasted about 100,000 years. This event probably left these bubbles. In 2023, the James Webb Space Telescope took a striking, super detailed image of the so-called Herbig-Haro objects. These objects are called Herbig-Haro 46/47. They're basically young stars surrounded by beautiful patches of nebulosity. You can see the stars being surrounded by a disk of material that feeds them as they grow for millions of years. They're located at about 1,470 light-years away, but they're actually not our main topic of discussion. What's much more interesting is this weird thing right below them, a space structure that looks like a question mark. What is this thing? No one knows for sure. It has an orange-red color, which hints that it might be super distant, far from our galaxy, maybe even billions of light years away. Some think that this strange question mark is probably the result of 2 or more galaxies merging together. One of them was a bit curved, so it's probably a distorted spiral galaxy. The curve might be the tails being stripped off as they spiral towards each other. The other one was rounder and smaller, like a regular spherical one. The gravity games never fail to amaze us. Astronomers started searching for extraterrestrial megastructures. They think that if there's another intelligent civilization out there, they could have built something incredibly huge to power their technology. For example, like Dyson spheres. Hypothetical structures around stars that use the star's energy as fuel. Astronomers analyzed some historical telescope data that detects infrared signals. They spotted some weird signals that could hint at the presence of these structures. In total, there are 7 such candidates right now. All of them are coming from red dwarf stars, which are redder, smaller, and less massive than the Sun. Another research institute found 53 potential candidates. They're still not sure what exactly causes these signals, but it could be not Dyson spheres, but some huge debris. It looks like there are some mysterious structures in the center of our galaxy. In 2023, the James Webb Space Telescope has taken a detailed picture of the Sagittarius C region. It's right near the center of the Milky Way. This image showed a dense area where stars are forming. There were many young stars and dark clouds that blocked the light from the stars behind them. That's a very packed place, with about 500,000 stars of different ages, sizes, and colors. This place is very chaotic and extreme. Now, scientists are using it to study star formation. But the weird part is that they noticed something else: the large region of ionized hydrogen. It looks like cyan in the image. This area is about 25 light-years long, surrounding the lower side of dense cloud. And it looks like there are some needle-like structures. They seem to be located randomly, and astronomers have no idea what they are. So now they have to study this in more detail. Astronomers have found a super rare, massive galaxy. It's called JWST 7329, and it's absolutely ancient. Our entire universe is about 13.8 billion years old, but the stars in this galaxy seem to have formed around 13 billion years ago, so just around 800 million years after the Big Bang. Also, this venerable elder has 4 times more mass in stars than our Milky Way does today. This strange discovery challenges what we know about galaxy formation and the nature of dark matter. Everything we know tells us that galaxies shouldn't have formed so early. There shouldn't have been enough dark matter for that, but here we are. So, perhaps our models need some revision. There was an incredible astronomical event called AT 2021 LWX, which is also called Scary Barbie. It was an unbelievably bright burst of energy that happened on April 13, 2021. It's one of the most energetic space events ever observed. No galaxies or quasars were nearby. So what in the world happened? At first, astronomers thought that it was caused by a supermassive black hole pulling in a massive star. But after some studying, they think it's probably because a giant black hole had some crazy dinner. It probably ate a large amount of gas, possibly a giant molecular cloud. The titanic black hole in question is between 100 million and 1 billion times the mass of the Sun. This is one of the most massive known and active black holes. Astronomers found the oldest strand of the cosmic web ever seen. The cosmic web is what we call a huge structure of the universe that's made of interconnected filaments of galaxies and dark matter. They're like a framework for galaxies and other structures, playing a crucial role in their formation. The filament we're talking about is made up of 10 closely packed galaxies. It's unimaginably huge, stretching over 3 million light-years. And it looks like the newly discovered strand is very ancient. It occurred only 830 million years after the Big Bang. It's probably anchored by a luminous quasar. This discovery makes us question how exactly galaxies are formed and what exactly happened to our universe after the Big Bang.
Ruh-roh, there might be another universe, like a dark mirror image of ours, where time flows in reverse. This flipped-over world might also be the source of dark matter, the invisible substance that's all over our universe. There might also be many more universes out there, in which an exact copy of you woke up this morning, but it chose a white t-shirt instead of a red one, sending it on a completely different life path. But let's start with this elusive dark matter. It makes up most of the universe's mass, yet we're not sure what exactly it does or where it comes from. That's because it doesn't act like regular matter. We can't see it or feel it. We just know it's there because of how it seems to bend gravity. Even though regular matter and dark matter are very different, they seem to exist in a balance. Some scientists think this must be connected somehow. A new theory suggests that for every way regular matter moves, there's a mirror version of it in the world of dark matter, like a bridge connecting the two worlds. There's also a strange coincidence in regular matter where a neutron and a proton have almost the same weight. This allows them to stick together and make atoms stable, making everything that we can see with our eyes exist. If protons were a bit heavier, there would be no balance and atoms wouldn't form. In the dark mirror universe, maybe things happen differently. Maybe in there, the equivalent of a proton doesn't bind to other particles, leaving behind lonely neutrons, which could be the source of dark matter. This theory also suggests that dark matter might have its own chemistry, like dark atoms and a dark periodic table. For the longest time, scientists believed there was just one type of dark matter. Although these particles are similar in some ways, like being almost invisible, they may vary in their sizes, speeds, and how they affect regular matter. If this idea is right, it means there could have been interactions between our universe and the dark mirror universe in the past. Studying how elements formed in the early universe might give us clues about this. The idea of a flipped world has sparked curiosity and even some confusion in the scientific community in recent years. Astronomers use a theory called the lambda-CDM model to explain the composition and behavior of our universe. According to it, most of the universe is made of two things: dark energy and dark matter. Dark energy is like the pushing force that makes the universe expand faster. Dark matter is this invisible thread that pulls things together with its gravity, acting like a universal glue. Regular objects, like stars, planets, and comets, only make up a small part of the mix. The model also tells us about the Big Bang, and how everything started from a hot, crowded beginning, and how the universe has been growing and changing ever since. While this model seems to be correct in many ways, it doesn't explain all cosmic phenomena. If you were to draw this model on a piece of paper, it would look like a series of flat pancakes stacked on top of one another. Each one of the pancakes represents a rendition of the universe at a certain point in time. Yesterday's universe would stand below that of today, but it would be a slightly smaller pancake. By the end, you'll see that the universe's history looks like this giant upside-down cone, with its minuscule tip being the Big Bang. Beyond this point, we can't see any further away in time with the tools we have, so we don't know what's beyond. More so, we're still not even sure what happened immediately after the Big Bang. But if we simply apply the math, the universe might go beyond this historical tipping point, which could mean it could go in reverse, creating a similar mirrored cone where time would flow backwards, in our perspective at least. This alternative idea not only challenges our understanding of cosmic origins, but also raises questions about fundamental principles in physics. All the excitement around a mirrored universe also came from Anita, a scientific instrument stationed in Antarctica, and its discoveries. This device saw some weird high-energy particles seemingly bursting from beneath the Antarctic ice. The problem with these particles is that they didn't behave as the laws of physics dictate. Scientists think they have a type of cosmic rays. They travel from space through the Earth and back out again. But the particles we already know about shouldn't behave like that. That's because higher energy particles usually collide with something inside the Earth and don't come out the other side like these do. They seem to be doing things both forward and backward. For now, there's no concrete proof of a mirrored universe. These particles could simply be ones we haven't discovered before, and scientists need to study them closely to come up with a definitive answer as to why they're behaving like this. Kind of like 4-year-olds. But what if there isn't just one other universe, but many more? This multiverse concept comes from ideas like the inflation theory, which says that our world had this rapid expansion in its early stages. While inflation stopped in our neighborhood billions of years ago, it's likely that it continues in other regions of the multiverse, creating different universes with their own laws of physics and unique characteristics. Our universe is the only one that we know of that can support life. We have stable stars that can provide heat and warmth, for example, which is crucial for creatures to start moving around. We also have an abundance of elements like carbon and hydrogen, which we also need to exist. The multiverse hypothesis gives an explanation for why our universe exhibits such life-friendly conditions. It may explain that there are countless other universes out there, with varying conditions, making the existence of life in at least one of them less likely. One fascinating implication of the multiverse theory is the idea of doppelgangers, these exact copies of individuals existing in parallel universes. This notion suggests that within the vast expanse of the multiverse, there could be infinite scenarios where identical versions of ourselves are experiencing similar events at the same time. Before we begin our travels to different universes altogether, we might need to understand our own. There's this galaxy, for instance, far from us, that might have no dark matter at all. It's about 250 million light-years away and looks normal at first glance. But if we look closer, we can't seem to find any dark matter. If it turns out that there are more galaxies like this one, it could change our ideas about how galaxies are made. Dark matter is usually thought to be necessary for this process, acting like the glue that holds the whole thing together. It is true, however, that this particular galaxy is more faint and has fewer stars than usual. When it was first discovered in 2019, scientists thought it might not have dark matter because of how fast it was spinning. The speed at which a galaxy spins tells us how much stuff there is in it. By comparing this speed with what we can see, astronomers can figure out how much extra stuff, like dark matter, must be there. And in this unique galaxy, the math says there isn't any. Among all these theories, there's also one that says dark matter might not be real at all. This new study proposes that maybe we've been looking for something that doesn't even exist. They think that our understanding of gravity might not be good enough to explain why some galaxies behave oddly. So instead of dark matter causing these weird behaviors, they say it might just be that we don't fully understand how regular matter works. They base these findings on a theory called modified Newtonian dynamics. It suggests that gravity behaves differently at very large distances or very low speeds. Strange explosions in vibrant blue colors are popping up around the universe and keeping astronomers intrigued. This rare and incredibly powerful event has a fancy name: luminous fast blue optical transient. This phenomenon doesn't behave like anything else we know of, and things got even stranger when the most recent one happened in a spot it shouldn't have. To really understand what happened last year, we need to go back a bit. This type of strange explosion was spotted first in June 2018. The blue blast happened about 200 million light-years from Earth and got the nickname the Cow. No, this happening didn't resemble a cow at all, but it did have an unusual format. Back then, this blast was the most asymmetrical explosion ever seen by astronomers. It burst into space in a flattened pancake-like shape, not in a typical sphere as they would expect. This phenomenon was similar to a supernova, which is the most common type of cosmic explosion that happens when a star exhausts its nuclear fuel and collapses under its own gravity. However, scientists also noted three crucial differences. Number one, this phenomenon is more powerful than a typical supernova. When it happens, the blue burst emits more energy than an entire galaxy of hundreds of billions of stars like the Sun. Number two, it's much faster. The explosion reaches its peak brightness and fades away within a matter of days, while a supernova can take weeks or even months to completely dissipate. And the last difference, these blue bursts can also be much brighter. These mysterious objects are considered the brightest known optical phenomenon in the universe. But unlike a regular supernova, it's believed that there are no radioactive elements to power this brightness. So that means the power must come from somewhere else. The question is, from where? This is just one of the mysteries that the scientists are trying to figure out. There have been some heavy investigations since the event was first observed, and 15 telescopes around the world are constantly looking for it. Since 2018, these extreme explosions have been spotted about once a year. So while they're rare, they're not incredibly uncommon. There are several possible explanations for the existence of these fast optical transients. Perhaps the most acceptable one is that it is a stellar corpse. I mean, what is left behind when a star calls it quits. So we're looking at two prime suspects here. They could be a neutron star or a black hole, producing emissions close to the speed of light. The theory goes like this. There is a massive star much larger than those that produce regular supernovas. Then it starts to collapse. Such an event would certainly be expected to leave a black hole behind. Let's say this massive star isn't ready to leave the universe in a quiet way. Instead, it creates a swirling disk around the black hole composed of gas, dust, and other matter, like it matters. This disk, called the accretion disk, can shoot out streams of material at incredibly high speeds, almost like powerful cosmic jets. And that could be exactly what we see as those sudden bursts of light. Again, it's just a theory. What exactly sets off these blasts remains a mystery, and much more observation and analysis are needed. Experts believe that explaining such an oddity is a scientific goldmine. After all, we're talking about a stellar corpse that isn't just sitting there, it's actually quite active. Now, since this event was first spotted, all similar occurrences that our telescopes have captured happen in the same place. I mean, the explosions always occurred in the spiral arms of different galaxies. But last year, things changed. The Hubble Space Telescope left scientists speechless in April 2023 when its images caught this same type of weird explosion happening for the first time in the middle of nowhere. Well, it didn't happen inside a galaxy as it was supposed to. It happened in the space between two of them. More precisely, about 50,000 light-years from a large spiral galaxy and about 15,000 light-years from a small one. This event is known today as the Finch. Oh great. So when we finally get closer to finding some answers, the unusual location of the Finch phenomenon came to mess it up again. So maybe there is another explanation for it. Speculation began soon after the discovery. One idea is that it could have been a collision between two neutron stars traveling far outside their host galaxies. These two could have been spiraling toward each other for billions of years, and when they collided, they produced a flare over 100 times brighter than a normal supernova. For this hypothesis to be correct, one of these neutron stars would have to be highly magnetized, amplifying the explosion. Another possibility is that the explosion was a star being torn apart by a black hole with a mass between 100 and 1,000 times that of the Sun. Although we still have lots of questions, one thing is for sure. The Finch is a luminous, fast black optical transient. Except for the weird location where it happened, it has all the other characteristics to be classified as one. It's super bright, like me, and super fast, and its origin is super hard to explain. Plus, the data from the Gemini South Telescope, the Chandra X-ray Telescope, and the Very Large Array Radio Telescope have confirmed it. Adding this latest information only makes it harder and harder for researchers to finally find some kind of pattern in this whole event. The Finch isn't the only peculiar event in this category. Let's head back to the year before, to 2022. A blue explosion was spotted in September, and it got the nickname of Tasmanian Devil. Just like the previous ones, this blue burst came up and disappeared very quickly. Then, something mysterious happened. Exactly 100 days later, observers who were still tracking the phenomenon got an early Christmas gift. They observed another flare-up, and it was as bright and fascinating as the original one. Wait, so we're talking about two similar and strange explosions that happened at the same spot and close in time? Well, this was a first. Quickly, 13 telescopes around the globe all had eyes turned toward the Tasmanian Devil event, including one equipped with a high-speed camera. Over the course of 120 days, they managed to capture another 14 irregular light pulses. This was certainly amazing because it proved that instead of showing up once and fading away as expected, the Tasmanian Devil continued to explode with supernova-like energies again and again and again. Can you imagine such power? This scenario still intrigues the scientific community because it pushes the limits of physics, not only because such extreme energy production, but also because of the short duration bursts. By the way, its flares last from 10 minutes to about 4 hours. Believe me, on the scale of the universe, that's considered super quick. This was the only time that an extended season of this event was observed. However, after some thought, the scientific community split their opinions about it. On one hand, the Tasmanian Devil could have been an utterly unique and one-of-a-kind event. On the other hand, maybe it was just the first time that our telescopes caught it from a more face-on angle. To further understand what's happening, scientists still need to observe larger samples of the phenomenon. All hopes are in the upcoming Vera C. Rubin Observatory, which is currently being constructed in Chile. It will have a 27.5-foot wide telescope, coupled with the world's largest digital camera ever fabricated for this purpose. According to NASA, this technology might finally give us some answers about these blue explosions. We can expect some exciting times ahead, as this could be the start of a new chapter in our understanding of stellar evolution. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Marsquakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist. We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with the magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them. Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future.
About a third of all grown-ups have a snake phobia. But if you decide to become an astronaut not to have to deal with them, it might not be a great idea. According to Story Musgrave, there are snakes in space. Musgrave is one of the most experienced astronauts in the world right now. He is the second astronaut who managed to go on 6 space flights and fly on all the space shuttles. With that much experience and time in space, he has to have 1 or 2 space horror stories in his career. Once on a space mission, he looked out of the window and saw something resembling a snake. Musgrave said it was 6 to 8 feet long and looked like a snake, but many people don't believe his story. They claim it was some trash floating in space or something that had detached from the spacecraft. But the astronaut went on another mission and saw the creature again. The first time he spotted it, it could be some detached piece from the spacecraft. But what are the chances of that happening twice? He gave many interviews in which he explained these crazy encounters. Let's hope those snakes stay in space and don't come crashing down on Earth. If they are real, of course. Snake rain would not be fun. As we all know, space is like a giant vacuum chamber with 0 air, and sound can't travel there, making this story even more terrifying. To communicate, astronauts have a special system in their suits to exchange information. Young Li Wei shared his terrifying experience, and it's hard to believe it actually happened. You would be terrified if you were alone at home and someone started knocking on your door at night. Of course, if you weren't expecting anyone. Imagine the same scenario, but you're in space. You hear some knocking, you have nowhere to run, you're trapped in a metal can floating into nothingness. Young was sitting in his spacecraft, minding his own business, when he suddenly heard knocking coming from outside. How is it possible? Sound can't travel in space. The noise was unique. The astronaut described it as if someone had been knocking on an iron bucket with a wooden hammer. Li Wei looked outside, but to his surprise, there was nothing there. He investigated a bit more, but couldn't find the source of the sound. When Young returned to Earth, he was eager to tell scientists about what had happened, but he could not recreate the sound. To add fuel to the fire, his colleagues, who were on the same mission from 2005 to 2008, said they had also heard knocking similar to what Young had reported. This is still a mystery. Nobody knows what happened then. Maybe it was just spacecraft noise, like those your house randomly makes. We've already mentioned that sound can't travel in space, but that doesn't stop weird noises. The Apollo 10 mission was one of the most significant space missions ever. So, astronauts had to ensure everything was perfect before they went on a moon exploration journey. 3 people were on that mission: Thomas Stafford, module pilot John Young, and lunar module pilot Eugene Cernan. They had to do tons of gear tests for the upcoming Apollo 11 missions. The astronauts were circling the moon when they heard music coming from somewhere. It wasn't like Ed Sheeran's concert, it was more like constant loud screaming. Then, it was quiet whistling. They were terrified. Imagine being in space for the first time and hearing weird noises. The sounds lasted for a whole hour. The astronauts had never heard anything like that before. The sound was otherworldly and creepy. When they returned to Earth, they didn't know if they should tell someone about their experience because it was hard to believe. Michael Collins, an astronaut from the Apollo 11 mission, later shared that he had also heard this sound. But there is a kind of logical explanation for this. Engineers from NASA said that the sound that they had heard had been caused by the interference with the communication system. So you can relax and throw your tinfoil hat in the trash. But before you do that, Al Worden, an astronaut from the Apollo 15 mission, said that this explanation was unlikely, so we might never find out what really caused the sound. Leroy Chiao was the commander of the International Space Station in 2005. When it comes to space, he's seen a lot of things that can send chills down your spine. One encounter he and his crew had will live on in their head rent-free forever. Chiao was sitting in the space station doing his job when he suddenly spotted light from the corner of his eye. He took a closer look, and it resembled an upside-down V, floating and glowing in space. Leroy later explained that he hadn't been scared by the object. Quite the opposite. he was extremely excited to see it, even though he had no idea what it was. His crew also saw the strange object. Chow was convinced he was visited by something not from Earth. His team could also vouch that indeed they saw something unexplainable. The information about this encounter is all over the internet, and many people are skeptical. It could have been anything. There are more than 10,000 satellites in space right now. It could have been a satellite floating in space. Another theory is that those were lights reflecting from a fishing boat on Earth. But who knows? There may be another logical explanation for this phenomenon waiting to be discovered. Horror stories don't stop there. This one is hard to believe, and it's up to you to figure out if it's true. Astronaut Alan Bean was the fourth individual to set foot on the Moon's surface. When he was on the Apollo 12 mission, he claimed he saw a unique shape on the Moon. It was shiny and shaped like a shoe. It's hard to know what he saw because he passed away in 2018. Chinese lunar rover Yutu-2 also discovered some shiny substance on the Moon. Scientists say it was something gel-like. It could be a glaze that formed when something impacted the Moon's surface, like a meteorite or something else. But in the future, we might find a better explanation for this strange find. This may sound wicked, but many countries send animals to space before humans follow them. Take Miss Baker, a squirrel monkey, Ham the chimp, and many more. Many of these animals returned to Earth safely and lived happily ever after, like Ham the chimp that lived for 26 years. But some weren't so lucky. Astronauts are still creeped out when they see animals floating in space. Imagine seeing something like that in a dark vacuum. No matter how tough you are, after that, you will be afraid of your own shadow. This may be sad, but it was an essential step in space exploration. The following horror story comes from space engineer Musa Manarov. This guy came across something that made scientists confused. He was shooting a video of space when he accidentally filmed some shiny object flying in the distance. The thing had a cylindrical shape, and Manarov thought it was something that had detached from the spacecraft. But he was unsure because it moved in a unique way. When you think of a creepy space story, the first thing that comes to your mind is some creature crawling on the spacecraft, or some weird object flying in space. But all those things are highly unlikely to happen. When somebody asked Chris Hadfield what the scariest thing about space was, he said it was asteroids. There are thousands of them in space, and the spacecraft is constantly getting hit by them. Chris said that he'd always heard sounds from asteroids hitting his spacecraft. He also mentioned that the spacecraft's solar panels were covered with holes. And you never know whether a giant asteroid will come and hit your spacecraft.
Now, in the 70s, we received a radio signal that lasted more than a minute, and to this day, no one knows what it was or where it was coming from. But now, a new theory has appeared. Could the mystery finally be solved? In 1977, at 11:16 p.m., a telescope in Ohio caught something very unusual in space. It was a super short radio signal, just 72 seconds long. The signal was so strong and weird that the scientist who found it wrote "WOW" in red ink next to it. That's why it's called the WOW signal. Now in space, hydrogen gas sometimes releases radio waves, a type of electromagnetic radiation. They emit at a specific frequency, which is like a unique signature for hydrogen gas. This helps us to find, identify, and study it. Thanks to this, we noticed that the WOW signal frequency came from the same place as this gas. But it's not like it helps much, because we still have no idea what emitted it. What's even stranger, the signal happened only once. Even though we tried really hard to hear it again, we never did. And without a repeat signal, it was impossible to tell what it was. It's hard for us to even get its precise location because the signal was short-lived. After a certain distance, it's very hard to tell where different radio signals are coming from. And that's where the theory started. This particular frequency that the WOW signal was on is special. It's not crowded with a lot of other signals. It's like finding a quiet spot in a noisy room. Because there's not much interference or noise, so if you send a signal on this frequency really far, it won't get lost or distorted. And that's curious, because it means that there might be a perfect place to send messages if we want to communicate with any extraterrestrial creatures out there. So, could it be that they're trying to contact us? Well, it's a real scientific possibility. No one knows for sure what caused the WOW signal. But if it was from something extraterrestrial, they definitely communicate not like we do. The signal looked nothing like a deliberate message, and that's weird that it happened only once. If it was little green people trying to contact us, it would be weird for them to only try once. But, just in case, in 2012, on the 35th anniversary of the WOW signal, we decided to send out a bunch of messages toward certain stars. We used a special code to make sure any extraterrestrial creatures who got the messages would know they were from intelligent beings like us. Well, mostly intelligent. We even used a lot of power to make sure the messages could travel really far. Scientists have come up with lots of ideas about where the WOW signal might have come from, but none of them are widely agreed upon. We know for sure that it didn't come from anything on Earth. Earth noise can interfere sometimes, but this signal definitely came from outer space. There was also a theory that the signal might have bounced off some space junk and come back to Earth. But later, we realized that the requirements for that to happen were very unlikely. One potential idea is that the signal might have been caused by twinkling in space, like how stars twinkle in the sky. But even if that's true, it doesn't rule out the possibility that the signal was made by something artificial. Another idea is that it could have come from something spinning, like a lighthouse. Or maybe it was a signal that changed its frequency over time. Or it was just a one-time burst. It's been 50 years since a strange radio signal was caught. But recently, a new idea about its origin sparked up. Now, imagine a comet streaking through space, leaving a trail of gas behind it, like a tail. This gas could be key to understanding the mysterious radio signal that caught astronomers' attention all those years ago. One of the astronomers looked at the WOW signal and thought it might be connected to a comet called 266P/Christensen. Yeah, that's a mouthful. This comet is about 1,800 light-years away. It wasn't known back in 1997 when the signal was first detected, but now it could explain the strange radio waves. Comets can emit radio waves as they get closer to the Sun. It's like the gases around them start buzzing with energy. This buzzing might be what the WOW signal was all about. To test this theory, we used a radio telescope to listen for radio waves from other comets. We found that some comets did indeed emit radio waves at the same frequency as the WOW signal. Then we pointed the telescopes at this particular comet as it passed through the same part of the sky where the WOW signal was detected. The comet's radio waves could match up with the signal, and while the comet wasn't exactly in the same spot as the signal, it was close enough to feel like we were onto something here. It also might have been caused by hydrogen clouds from two comets, the ones we mentioned and another one called P/2008Y2. Who picks these names? But not everyone is convinced by that idea. Some say that the theory about two comets causing the signal doesn't add up, because comets don't usually emit radio waves in the ways needed to explain the WOW signal. Also, the signal didn't repeat itself, and only happened once, which is weird if it's really a comet. They spread out their gases over a large area, so the signal would have lingered longer. The telescope used to detect the signal should have picked it up twice in a short time span, but it didn't happen that way. Also, the comet wouldn't have moved out of the telescope's view so quickly. This shows that we need to learn more about how and why comets emit these radio waves, especially at the same frequency as the WOW signal. There are also a lot of mysterious and interesting signals in space. Most of them come from natural events, like something called fast radio bursts. These bursts of energy are incredibly powerful and occur all over the sky, but their origins are still unclear. They last for only a fraction of a second. Maybe the telescope caught just a part of one of these bursts. There's also a strange signal we've been receiving since 2018. This one actually repeats every 22 minutes, but despite our efforts, we can't figure out where it's coming from. It started way back in 1988, and we've been investigating this mystery for 36 years now. At least here we know the distance of the mysterious object sending the signals, a distant 15,000 light-years away. Some speculate that these signals could be from extraterrestrial beings trying to communicate with us. However, we can't say for sure without solid evidence, so it remains speculative. Another explanation is a pulsar theory. Now, pulsars are neutron stars that emit beams of energy, similar to what we've been observing with the signals. However, the behavior of the signals doesn't perfectly align with what we know about pulsars. There's also the magnetar theory, suggesting that these signals could be coming from supercharged neutron stars called magnetars. Yet, none of these theories fully explain the strange behavior of the signals. Maybe there's a new, undiscovered phenomenon in the universe. So even though comets are a possibility, there are still a lot of unanswered questions about the WOW signal. We don't know what caused it, and we may never know. We don't even know if it came from deep space or from somewhere inside the solar system. In any case, even if the WOW signal had a natural cause, it doesn't mean that extraterrestrial life doesn't exist. The study that talked about this also discussed a sun-like star that could be a great place to look for signs of technology from space. There are 14 more stars similar to our Sun in space, although we're not totally sure about their brightness. This opens up exciting possibilities for hunting down signs of advanced civilizations beyond Earth. Ooh. Just watching certain scenes from the movie Gravity was scary, let alone imagining what would happen if you really ended up in the cold, endless void called space without knowing if you'd be able to go back. But let's say you're really up there. You're so excited about your first spacewalk. It sounds risky, but it's something astronauts on the International Space Station do quite often. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they've failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step: activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. That's why they go through pretty intense training sessions, so they can remain calm even in very stressful situations. A long time ago, NASA would choose astronauts from test pilots who went through harsh training in the jungles of the Philippines without any help, so no instructions or supplies. Later, they implemented a special training regime with outdoor exercises in different climate environments and even underwater to simulate conditions in space. Today, astronauts are trained to work in teams to stay focused and calm while handling difficult tasks. For instance, when they needed to fix the Hubble telescope, astronauts had to work for more than 8 hours in the harsh conditions of space to remove a broken part. It was a frustrating task. Plus, the gloves they had to wear made things harder, but they still did it. They also train in a giant water pool in Houston, which is a pretty good replica for the ISS. That's where they practice spacewalks and try to repair things while being underwater all the time. The water makes them feel weightless, while their suits are heavy enough to mimic the effects they could experience during spacewalks. You also need to have sessions with aerospace psychologists. They help astronauts handle stress and stay mentally strong. They check astronauts before, during, and after missions, helping pick the best candidates for spacewalks. Not everyone can go through these harsh conditions. Out of 16, only 10 get chosen. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. When up in space, a lot of things can go wrong, and sometimes even astronauts' training and equipment can't help solve the problem. That's where the Mission Control Center on Earth jumps in. Thousands of people work on Earth to support the astronauts on the ISS. But if the communication system doesn't work, or no one's close enough to help, that's where the rescue operation stops. You just continue to move in a random direction, waiting for the 7.5 hours of air you have to run out. Feeling hungry? Unfortunately, you can get nothing but some water you have in your helmet. Maybe you'd stop spinning at some point. The view would be fascinating. You could watch the Earth rise and set about 5 times, depending on where you are. And while you'd be getting farther away, and Earth would be turning into a small dot lost among asteroids, stars, and space debris, a random picture would come to your mind. A stunning sunset at the beach, the sound of waves, and your favorite pizza. Now, it's so far, it almost seems like part of another dimension.
Picture this. You're floating about in the depths of space, gazing down on our blue marble of a planet. What's on top? You might think it's the North Pole. But that isn't necessarily so. The truth is, our collective belief that the North is at the top of the world doesn't have any solid scientific backing. It's just one of those things we've accepted over time. And this acceptance has a compelling history, with a dash of astrophysics, a bit of psychology, and a surprising twist. It influences how we feel about our world more than we might think. Figuring out where you are is crucial for survival, and that's true for most species, not just us humans. Similar to honeybees, for example, humans have a knack for creating mental maps of our surroundings. But where we really stand out is in our efforts to share these maps with others. We've been at it for a while now, drawing maps on anything from cave walls to computer screens. The earliest ones we've found date back to 14,000 years ago. Despite this long history, it's only in the last few centuries that we've decided that the North should consistently be at the top of the map. History buffs tell us that for a long time, the North was hardly ever at the top because it symbolized darkness. The West didn't make the cut either, given that's where the sun bows out each evening. However, early Asian maps seem to defy this trend. Now, before you say it, their compasses weren't the reason they put North at the top. Early Asian compasses were actually aligned to point south, seen as a more favorable direction than the cold, dark north. But in these maps, the emperor, who resided up north, was always placed at the top, with his loyal subjects gazing upwards towards him. Looking back, every culture had its own idea of what was worth looking up to, leading to varied orientations of early maps. The Egyptians preferred the east, where the sun graces us each morning. Early Arabic maps favored the south. European maps from the same era put the east at the top. So, when did everyone decide that north was the new top? You might be tempted to credit it to explorers like Columbus and Magellan who navigated by the North Star. But they didn't really see the world in that light. Columbus, for instance, saw the world with the east at the top, believing he was headed toward paradise. Mercator's 1569 world map was a game changer, considering it was the first to factor in the Earth's switch to more accurate navigation. But even then, the emphasis wasn't on the north. Mercator projected the poles to infinity, considering them relatively unimportant as sailors didn't venture there often. It's possible that the choice to place north on top was simply because the Europeans, who were doing their fair share of exploring, were located in the northern hemisphere with a whole lot more land to cover and people to meet. For whatever reason, this north-up idea has stuck. Even when a NASA astronaut in 1972 snapped a photo of the Earth with the south at the top, it was flipped over to avoid confusion. Here's where it gets interesting. When you gaze at Earth from space, the concept of up and down loses all sense. Sure, Earth aligns with the plane of other planets in our solar system because we all share a cosmic birth story, but we could just as well flip the image or put the sun on top or bottom depending on your cosmic viewpoint. Even within the Milky Way, our solar system is tilted by about 63 degrees. If you think about it, the concepts of up, down, left, or right don't really apply in space. But how about a change of pace? Should we be open to viewing our world from a different perspective? There's some psychological evidence that our north-up mentality might be skewing our perceptions of value. Most folks consider the north to be up and the south down. It even made psychologists wonder if these associations might influence how people value different places on a map. When shown a map of a made-up city, people were more likely to choose a residence in the northern part. And when asked where hypothetical people of different social status would live, they allocated the rich to the north and the less fortunate to the south. It's not too big of a leap to speculate that humans might be less bothered about what happens to regions lower than where they are on the map. But there's a simple solution. Flip the map upside down. These experiments showed that this simple action wiped out the north equals good bias. On that note, south up maps are already available online. Australians would enjoy this change, that's for sure. Whatever it is that you'd prefer at the top of your map, you would need a compass to guide you. Have you ever paused to think of its system? It is one of the oldest gadgets we've got in our survival toolkit. It's been around for centuries, serving as a beacon for adventurers, travelers, and explorers, guiding them through uncharted oceans and helping them discover new continents. Basically, compasses turned humans from stay-at-home types into globe-trotting nomads. Our beautiful blue planet isn't just a spinning ball in the cosmos. It also has its own magnetic field. Imagine it as a colossal magnet, humming with invisible energy. This is all thanks to Earth's core, a ball of molten iron under terrific pressure right at the center of our planet. This core, part liquid, part solid crystal, churns and swirls due to Earth's spin, creating the magnetic field that gives us our north and south poles. But here's where it gets a bit complicated. These magnetic poles don't perfectly line up with the Earth's geographic poles, the ones that the Earth spins around. They're close, sure, but not exactly in the same place. This is why the compass, which reacts to magnetic fields, doesn't point directly to what we call true north, which is the geographic North Pole. Instead, it points to the magnetic north, located a bit off from the true one. But don't worry, it's close enough to get us where we need to go. Let's talk more about this true north versus magnetic north business. Remember the piece of news from September 2019, when for the first time in over 360 years, compasses at Greenwich pointed to the true north? Well, that's quite a rare occurrence. Usually compasses point towards magnetic north, which isn't a constant spot on the map. It changes and drifts over time, following shifts in the Earth's core. On the other hand, true north refers to the geographic North Pole, a specific unchanging point on Earth's surface. So when you're holding a compass, it's really the magnetic north it's directing you toward, not the true north. Here's where things get even more fun. The angle between the direction of the true north and the magnetic north, as shown by the compass, is called declination. It's a fancy word for a simple concept. Now, because Earth's magnetic field isn't a simple, straightforward thing, it has its wobbles and dips. The declination isn't the same everywhere. It varies from place to place. Also, here's what it's made of. It has this tiny needle that's made from a metal that's been magnetized. Iron's a common one. They set this needle on a little pointy thing, or pivot, and let it float in some kind of liquid. Often, it's mineral oil or something similar. This lets the needle spin around and dance with the Earth's magnetic field. When you hold your compass flat in your hand, the needle settles down and points to magnetic north. Now, look at your compass and you'll notice these small markings. They're known as degrees, and here's the fun bit. The needle's red end always points north, and the white or black end always points south. That's your compass's north-south dance. Plus, there's often an arrow on the compass case, right at the top. That's your orientation arrow. You've been training for this for years. You know you're ready. You're standing on the door's threshold. You take a deep breath and bravely open it. You jump outside the International Space Station and into the vastness of space. Ah, this never gets old, you say on the transmitter device. You feel like a feather whenever moving through space. Except for the suit, of course. It's true what that guy told you one day. Astronaut suits limit your body's movement by 20%. For you, that means you've got a 20% higher chance of being clumsy in outer space, which is never good odds. There's not a lot of room for error during a spacewalk. You finally get to the docking port. You look around and see the part of the station that needs fixing. This is where other space shuttles dock when they come in from Earth or other planets. About a week ago, a shuttle coming from Jupiter miscalculated the landing and broke a piece of the port. You've attached the new shield to your suit's belt. Now all you've got to do is screw it on the station. You've spent hours training underwater to do this. You wore a heavy, hot, uncomfortable suit inside a pool in order to get the training you needed. Incoming! Sarah shouts on the transmitter. You don't even have time to ask what, as an absurdly fast storm of space debris catches you off guard. It shakes everything around you. You try to hold on tight to the strap that's keeping you safe, but oh no! A piece of debris just hit your helmet shield. Come in, Bob, are you okay? Sarah asks you through the radio. You got a bit shocked by the impact, but everything seems fine. The meteorites are finally gone, so you can focus on your task now. You pull the rope that's connecting the new docking shield closer to your body, but the other part of the rope has nothing on it. Zip. Nada. Oh my, you think to yourself. Come in, Sarah, we have a lost shield. I repeat, we have a lost shield. This is a pretty serious situation, and you are aware of it. Anything that falls into space can go into a collision route with the International Space Station or with other space vehicles. You try to remember your training, but your mind goes blank. This is worse than that one time you broke your girlfriend's favorite ceramic jar. Sarah, the other astronaut who's with you on the ship, is shouting words on the transmitter. Oh no, Bob. Tell me you didn't do this. This is a total catastrophe. I'm coming outside. You spot the shield under the ISS. It's the size of a medium-sized car door, and it's moving quite fast. Here's what can happen in this scenario. The shield could head back down to Earth and break into the atmosphere. It would probably catch fire and disintegrate on the way down, but anyways, it would make NASA and you look pretty bad. The other option is the car door-sized shield gains momentum, and it orbits all the way to hit the ISS, and you for that matter, or some satellite that happens to be in a similar orbit. Here's the thing. If you ever thought that space was an infinite void, you got that part wrong. Since different countries started to build equipment strong enough to travel in space, space has been more crowded than ever. Not with people, but with satellites, asteroids, and space debris. You were surprised when you learned that Earth receives meteorite showers every single day, but they're so small that no one on the surface of the planet notices it. They usually turn to ashes before hitting the ground, but that's not all. What just happened to you on this mission has happened on several other missions before. Astronauts keep losing stuff in outer space. So much so that NASA had to create a division to track down and monitor the orbit of all debris that is just floating carelessly around. You couldn't believe it when someone told you that there are over 23,000 softball-sized pieces of debris roaming around in space, and if we're talking about smaller objects, then that number goes up to 500,000. As you were about to unstrap yourself and dangerously venture through outer space without any protection, you notice Sarah has beat you to it. You can't let her do this alone, so you decide to tag along. FYI, this is against every NASA handbook and training you ever received in your life. But you think, if this works in sci-fi movies, it must work for us. Even though we all know that's very far from the truth. Sarah's close to the debris shield, but her body weight makes her orbit in a completely different direction. Okay, you think to yourself, this is your turn to shine and be a hero. You try moving your arms like you would do underwater, but there's no friction in space. Duh. You can't butterfly swim your way to rescue the rogue equipment. You try to contact Sarah, but she doesn't come in. I guess you're on your own now. For some reason, you start to orbit in a similar route as the floating car door shield. It must be the amount of stuff you've got strapped onto yourself. Or maybe it was the breakfast burrito you had that morning. You feel like you're George Clooney in the movie Gravity. No, better yet, you feel like Obi-Wan Kenobi. Yes, you're feeling as strong and powerful as a Jedi right now. You keep your hands stretched before your body, hoping you'll gently collide with the space debris. And 3, 2, 1, and the landing was successful. Just joking, but yes, you managed to dock onto the debris. Hooray. Now what? You think? Guess you needed to have gone through that plan of yours a little bit more, huh? You still have no way of steering the debris. And now, you have no way to contact Mission Control and tell them the object, and yourself, are en route to somewhere. Don't get scared. You didn't come this far to get scared. What's the best thing you can do? First, take a mental picture of the Earth. It never disappoints from up here. Then, you try to play out the possible scenarios that could happen in the situationship you're in. Your normal body weight would not be enough to get you out of Earth's orbit. In the hypothetical scenario in which this did happen, you'd probably be vacuumed into Venus's orbit, and spend a quite unpleasant period of your life around immense heat. Even though in Greek mythology, Venus represents love, there is nothing lovely about orbiting close to this planet, and you know this. If you got too close, your spacesuit would never be able to take on the heat. It's only made to sustain temperatures of around 250 degrees Fahrenheit tops, and Venus's atmosphere can heat up to 700 degrees Fahrenheit. But honestly, the worst-case scenario is much simpler than that. Your spacesuit could decide to drown your ears, nose, and mouth in water. Yup. This has happened on spacewalks before yours. You see, in order to keep your spacesuit chill and cool, the suit relies on a gallon's worth of water that makes up for a cooling system. This system, which is supposed to send recycled air into the back of your helmet, does leak sometimes. And since you're stranded in the middle of the big nowhere, you'd have only that nowhere to run. But wait, what's that popping up on the horizon? It's a modular space shuttle. You try shouting, but nobody can hear you outside your helmet. You wave with your hands, but it's coming straight at you. Finally, it took longer than I wished to find you, Sarah said. Apparently, she made it back to the space station just in time to catch you before you went definitely rogue. Guess I'll be losing some astronaut points for this little misadventure, huh? You say. And yes, you definitely will. Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh, well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing: organic molecules. The galaxy in question has a long name, SPT 041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name: a polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part: they're considered the basic building blocks for life. Imagine that, life's building blocks. Those tiny carbon chains being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future. Houston, we've got good news. A group of select humans is being interviewed to hop on board the first commercial vacation to outer space. The space agency has given you a survey to answer. They want to know what you would pack on this space adventure. Depending on your answers, you just might be one of the chosen ones. Now, how about we take a look at that list together? Pencils. I guess I never would have thought of that, but it makes sense. Legend has it that the US spent millions of dollars trying to design a pen that worked in space. You know, since the lack of gravity is a huge, inescapable factor of life in outer space, pens don't work. The ink won't flow down as it does here on Earth. It turns out that pencils will do the trick. This way you can play word puzzles with the other space tourists, or even make some drawings of your adventure. You'd never forget to pack a toothbrush, of course. According to veteran astronauts, toothbrushes are so simple, yet their technology is enough for space. If you were to squeeze a water bottle inside a spacecraft, the molecules of water would float around in small bubbles. But if you wet your toothbrush, it naturally holds the water in it, keeping it moist to receive your toothpaste. Oh, I was going to say funny socks. Glad that you beat me to it. Here are two things. First, there's not a lot of walking that goes on in space. People don't tend to touch the ground too much up there. And second, space isn't the best place to showcase your fashion style. Yeah! Astronauts tend to use special clothes while they're out there. And it will be no different for you as a space vacationer. So socks will keep your feet warm and fuzzy, but they'll also speak for your fashion interest. Maybe one day you'll wear a smiley face sock, while the other day you'll go for a Grinch-themed one. Of course, socks are pretty helpful on board an aircraft. They'll make you slide through stuff more easily. Next time I go to the convenience store, I'll remember to buy some wet wipes for your space travel. Experienced space travelers do love them. And it wasn't even NASA that invented them, huh? Since water is a no-go inside a spaceship, the best option is wet wipes. Better yet if they're scented. Astronauts even use different kinds of wipes. They buy the disinfecting ones and the ones to use on their bodies. Just make sure you know how to tell the difference between them when you're up there. There's a popular myth that says that NASA invented Velcro. But the truth is, we tend to think that everything that's used in space was invented by NASA for a very intelligent and specific purpose. It wasn't, though. Velcro was invented for mundane reasons back in the 1950s by a Swiss company. They were adopted by space travelers because they work as anti-gravity props. They don't erase gravity, of course. But you can glue Velcros into daily stuff and then hang them on the Velcro attached to the spaceship's walls. It's a very smart system, but best to take your own pair, right? If you're spending a long time in outer space, photographs from back home might come in handy. Choose them well, though. Since the spacecraft isn't all that big, the rest of the people on board will know which pictures you decided to bring along. Best to keep that Harry Styles poster back in your earthly bedroom, right? Just bring real pictures of people that you know and love. Did I hear pizza? A huge part of traveling and exploring new places is being able to taste different flavors of food. In outer space, that's a bit more complicated. But hey, at least you can take some pizza with you. Well, actually, you'd have to have it delivered to you in a cargo ship. This way, ingredients would come fresh and ready to eat. It wouldn't be the first time that people in space tried eating Earthling junk food. Some astronauts have even eaten crepes and hot dogs. Perhaps the best part of this pizza party would be that your food could float. Now, isn't this a super nice way to enjoy some Earth delicacies? As much as I understand your desire to pack a toilet with you on this space trip, that's virtually impossible. I mean, I understand you. Some people are attached to the toilets in their homes. and a space toilet is far from the ideal experience. But NASA has been improving their toilet system, and it's the best it's been over the years. So that will have to do. Here's something I would take as well: a laptop. But what good would it do in outer space, you might ask? Apparently, there is internet all over the International Space Station. So even if you're not spending most of your trip docked at the ISS, you could enjoy some Netflix on the days you spend over there. There is internet all over the ISS, apparently. Crazy, huh? And speaking of leisure, I love that you would take a yo-yo. I'm not sure how efficient it would be in space, since there's no gravity to bounce it back and forth, but it would be nice to see how a yo-yo reacts in a gravity-free environment. Oh, I love jigsaw puzzles. This would definitely be on my list as well. Imagine trying to build a jigsaw puzzle that keeps floating in the air. Maybe you'll have to create a system to avoid the separate pieces floating aimlessly through the spacecraft. But imagine once you finish that turtle puzzle, it will look like it's swimming around the craft. You can't pack a window, but they sure are an important part of life in outer space. Let's keep in mind some of the rules of the trip. Each traveler will have the opportunity to do one spacewalk during their time in space. This is already huge. Consider yourself lucky. Some elite astronauts only get to do one spacewalk during their entire career. That is so because spacewalks are risky and require a lot of training. But you'll get your training once you're up there. The thing is, all other days you'll be stuck inside a floating tin can. So windows will come a long way. They'll help to remind you where you are. They'll give you some perspective of space and Earth. Of course, you should take your camera. How else will you be able to register for this once-in-a-lifetime experience? Just make sure it works inside an aircraft or the ISS and you're good to go. Coffee? Don't worry, you don't need to pack your own. Up until recently, astronauts had to rely solely on instantly brewed cups of coffee when they were in space. But you're lucky that coffee experts have already solved this issue. Nowadays, there's the IS espresso machine. The machine itself is similar in size to an Earthling espresso machine. But to drink it, space travelers have to use a zero-gravity coffee cup, together with a straw. If you try drinking it regularly, you wouldn't get hot coffee to hit you directly in your face. Instead, the coffee would be glued to the bottom of your cup. I have to say I really stand this invention. Last, but not least, why not pack your guitar with you? I noticed you were missing a musical instrument. If this was a conventional flight, you might have to pay extra for luggage. But since it's all included, don't be shy and take your guitar. Astronauts such as Chris Hadfield take their musical instruments with them when they're in space. He even became famous for his version of Bowie's Space Oddity, up to the point that Bowie himself told him he lived Chris's version of it. It helps to pass the time, but it's also great for socializing. Can you imagine a pretend bonfire happening in the void of space? I can, and it looks super cool. Well, I think you're set to go. I'll personally call NASA and ask them to pick you as one of the lucky space travelers. See you in outer space, amigo.
Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of negative 418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads. And we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.